So now that you have been multiplying polynomials, we are going to divide polynomials. We're only dividing polynomials by monomials. So it's really just going to be doing what we did in the exponent rules multiple times. So not as bad as what you might think. So remember, when you have like bases, that you subtract the exponents. So that's going to be how things start. So here we go. Remember that division is typically written as a fraction, but in this case, what they're saying really technically should have parentheses around there, is all that, the whole thing, needs to be divided by the 4p. So I'm going to rewrite it just so it's a little larger here. 16p to the 5th minus 4p to the 3rd minus 12p squared. And then the whole thing, and what's going to be easiest to do this is if you create separate fractions. So each one gets its own 4p. Kind of like when you divide both sides of an equation, or when you're putting something in slope-intercept form, that each part. So every term is getting divided by that 4p. Not just one of them, every single one. Then we do the same thing that we did with our exponent rules, where we're going to divide or reduce the fractions, the coefficients, and then subtract your exponents. So 16 divided by 4 is 4, and this p on the bottom, remember, he counts as 1 as far as his exponent. So 5 take away 1, this is p to the 4th. 4 divided by 4 is 1, and in fact it's a negative 1. And then 3 take away 1, this would be p to the 2nd. And as we've talked about before, it would be typical that we would not write that 1. It's okay if you do, but just know you wouldn't usually see it. Negative 12 divided by 4 is negative 3. And then second power, take away first power, would just be p. And there it is, done. So it's just like 3 small division problems wrapped up into one. Sometimes you'll see it already written in fraction form. You just want to still, whether you rewrite the whole thing or you just write 4x to the 6th under every part. So this should be in your notes, by the way. There is one page in there about special cases that we skipped over because I will use it during a lesson next week. And then each part is going to get divided by 4x to the 6th. So what's in the bottom is getting, because that's what it means. It means the whole thing because it was all in the fraction. So we're going to do each one individually. So 20 divided by 4 is 5. Subtract the exponents. 16 divided by 4 is 4. Subtract the exponents, so just x. Again, you could write x to the 1st, but... And then 4 divided by 4, this would be negative 1. And these x to the 6th, there would be no x's. They have just taken each other out. It would be x to the 0, which is 1, and 1 times 1 is just 1. So I'll need to go through all that. And that's my answer. So notice when something cancels out completely, like the 4's, the x's, in division, that doesn't mean 0, it means the whole thing is a 1. So at the beginning, this has 1, 2, 3 terms. Then at the end, it's going to have 3 terms. We might have one where there's actually a typo, and it has like terms to begin with, and that is just not typical, because if it had like terms to begin with, you would just take care of that first. Alright, so this one has a little twist to it. It is kind of like some of the problems you just did. So 24p to the fifth, I'm just rewriting, plus 2p to the fourth, plus 2p to the third. Just rewriting because no matter how big the space is, I just need it to be bigger apparently. Divide it by 6p. So each one of them gets divided by 6p. 24 divided by 6 is 4. And we know we've got p. 5 minus 1 makes p to the fourth. 2 divided by 6. We don't want decimals, so reduce that fraction. So that would be 1/3. And then 4 take away 1 would be p to the third. And then again, 2 divided by 6, 1/3. And this would be p to the second. And you might see this written this way. Instead of saying 1/3, it might just say p to the third over 3 plus p to the second over 3. So hopefully, looking at the fraction, like 2 goes into 6 3 times, but the 6 was in the bottom, so 3 is in the bottom, but the higher power of p is in the top. So these two things, this and this, say the same thing. We do have to be kind of careful to make sure that it doesn't look like, in this case, that it doesn't look like these p's are down in the bottom with the denominator, because that means a different thing. That would mean we were trying to divide by a higher power than we have on the top. So hopefully, if you have done the quotient rule, this is like one of the easier things you'll do. This is one of the times that division is going to be faster than the multiplication because it has fewer steps. And because we won't be having division with a trinomial and a binomial. And that is it as far as what you have there in your notes. I'm going to show you a couple other problems here from my old paper copy. To show you the other kind of things, what happens in a spicy problem as it's worded here. So we had, just now, we had problems that had fractions in them. And I cautioned you about where you exactly write the variable so that it doesn't look like it's in the denominator. And here we're going to see why, because in this case, when I write 6p to the third under each part, don't have myself very much room here, 3 over 6 is 1/2. And there's no p's in this first term because third power, p's are gone. 2 over 6 would be 1/3, but the higher power of p is in the denominator. So I would need to very distinctly extend that line and place the p, the variable, in the denominator. It should not be like out and kind of level with the middle or something. It needs to be very obvious that it's in the denominator. And then the last part, 3 over 6 again, 1/2, and then there's 2 more p's in the bottom because 3 take away 1, but the higher power again was in the bottom. Sometimes they won't even reduce. So here we're dividing by 8n to the third. So 24 divided by 8 is 3, and the n's to the thirds, n cubes cancel. 16 divided by 8 is 2, but then the higher power of n is in the denominator, so it's going to look like that. And then 3 over 8, that doesn't divide and it doesn't reduce. It's just going to stay 3 over 8. And then the higher power is in the denominator, so there's going to be an n to the second down here in the denominator below, with the 8 below the 3. So these get messier. That's why these are called spicy problems. So number 19, I'm dividing by 9n squared. Every single thing by 9n squared. So 3 over 9 is 1/3. Or I could think of that as just a 3 in the bottom. And this has a higher power on top. So the n is going to be up there on top. 9 divided by 9 is 1. The n squareds cancel out. If there's a part that is exactly the same, that just becomes the whole number 1. So anything divided by itself is 1. And then 2n over 9n squared. So 2/9 does not reduce. Higher exponent is in the bottom by 1. So pause, write down number 18, try it, and then see if you and I got the same answer. Okay, 5 over 10 reduced to 1/2. X's cancel out. 10 over 10 is 1. The x belongs in the denominator because there's one more higher power in the denominator. 5 over 10 reduces to 1/2. So hopefully you didn't start erasing if you had that. And then cubed minus 1 would make x squared. All right, so hopefully that helps with division. Thanks.